Yes, I want us to look at anomalous expansion of water. I said yesterday that the term anomalous means unusual. So anomalous expansion of water is the unusual behavior that water exhibits when it is heated at certain temperature. The anomalous expansion of water occurs at a temperature of between 0 degrees and 4 degrees C. Now, during this time, between a temperature of 0 degrees and 4 degrees C, the water contracts when it is heated. Take, for example, if you heat water, the ice, from a temperature of negative 20. From negative 20 to 0, the ice will be increasing in size. At 0 degrees C, that ice will be seen to melt. It changes into water, liquid water, without any change in temperature. Once all this ice has melted into water and you continue heating this water, now from 0 degrees, the water will be contracting instead of expanding. That will happen between 0 degrees C and 4 degrees C. So at that particular temperature, when you heat water, instead of the water expanding, the water will contract. That is the unusual behavior that the water shows, and that is what we call the anomalous expansion of water. Because we always expect that if you are heating any state of matter, be it a solid, be it a liquid, or even a gas, it should be expanding. But now here comes a case whereby we are heating water between 0 degrees C and 4 degrees C, and instead of the water expanding, it contracts. So that is a very unusual behavior, and this one we have to know that is only exhibited by water. Now, during this time, during this range of temperature, 0 degrees C to 4 degrees C, the volume of water decreases as seen in this graph here. Between 0 degrees C and 4 degrees C, you can see the volume slumping, the volume decreasing. When it reaches 4, the volume will be seen to expand, or maybe the volume will be seen to increase once again. So 0 degrees C to 4 degrees C, there is anomalous expansion. So just know that at that particular range of temperature, if you are heating water, the water will contract. Then once it surpasses 4, let's say from 5 degrees C, you are still heating, but you will notice that the volume of the water will increase to signify that this water is now expanding. Now, during the time when the water is undergoing the anomalous expansion, when the volume is decreasing, the density will be increasing. So the density of water between 0 degrees C and 4 degrees C, as you heat it, the density will be seen to rise. Now, why is this possible? We talk about density being equal to mass over volume. So if you look at the relationship between volume and density, they are inversely proportional. So during that time the volume is decreasing, the density is likely to increase. And when the volume starts increasing, as seen in this curve, the density will be seen to drop, as seen in this curve. So we have these two curves that show the relationship basically between volume and density during the anomalous expansion of water. I think that is okay. I think that is okay. So the one thing that is so important in this is that you know the range of temperatures during which the anomalous expansion takes place. Now, anomalous expansion has some effects. We have effects that the anomalous expansion of water exhibit. Number one is freezing of lakes and ponds. Now, during very cold periods, the surfaces of lakes and ponds freeze. They freeze. So I want us to look at something here. Yeah, I want us to look at this diagram. Now, in this diagram, we are seeing different temperature scales. At the surface of the water here, the surface of a pond or the surface of a lake, because the temperatures are very low on the Earth's surface, the surface of the lakes and ponds will freeze. When they freeze, they provide an insulator, a coating, in that the water below remains a liquid. The water below cannot solidify, even if the temperatures outside are so cold. The reason why this happens is because the water at the surface freezes. It turns into ice. Once it has turned into ice, ice is an insulator. So there is no cold air that goes beyond that ice or goes past that ice into the water. Therefore, that jacket provided by the ice that has melted on the surface will ensure that the temperature below the water surface is always constant. It does not change. So the living things, that the aquatic life, that is including the fish and the other aquatic animals, they continue living their lives without any threat of cold killing them or being affected by the cold. So that is an application or an effect that is caused by anomalous expansion of water. Number two, we have the icebergs. Now, an iceberg is a large volume of ice that has formed on the surface of water. But now when it comes to the iceberg, icebergs are very dangerous. You know that when we compare the density of water and the density of ice, ice has a lower density compared to that of water. So when water freezes to form that ice, the ice will melt. The ice will float on the surface of water. When this ice floats in the surface of water, it will pose some threat. Now, when you talk about an iceberg, this is the surface of water. There will only be a tip. So you can find something like this. You can find something like this. The whole of that is ice. The water that has changed into ice. So that is ice. Now, but the trickier part of this is that only a small part of this ice is floating on the surface. The rest is under the water. Now, this is very dangerous to the navigators, the people, the captains who are using the ships. It becomes very, very challenging to them because they cannot be able to see what is under the water. So the greater mass of this ice is underwater. So when these people are navigating, the ship might hit this submerged part of the ice, and that may cause the sinking of the ship, if at all it damages a part of that ship. So this is a very bad effect that anomalous expansion of water might have on the environment. The next one is weathering of rocks. Weathering of rocks means breaking of rock into smaller particles that end up forming the soil. Now, when it is raining, the water gets into the cracks of rocks. It gets into the cracks of rocks. This water will start freezing. As it freezes, we expect that it will be contracting. But when it reaches a point or that temperature, 4 degrees, let's say it is freezing from around 10 degrees C or maybe 20 degrees C. It's freezing from 20 to 10, maybe to 5. During that time, it is contracting. But when it reaches 4, towards 0, the water is already in the crack within the rocks, and then it starts expanding as it freezes between 4 degrees C and 0 degrees C. When it starts expanding, it will be exerting some pressure. It will exert some pressure on the rock. Therefore, the rock will end up breaking. This is what we call weathering of rocks. And weathering of rocks is the process that leads to the formation of soil. Finally, we have the water pipes. Water pipes can also be affected by anomalous expansion of water, because there is water inside these pipes. There's some water inside these pipes. So let's say, for example, this is a pipe. There's water that flows in this pipe. This water might freeze. This water might freeze. As it freezes between 4 degrees C and 0 degrees C, it will expand within this pipe. At that particular point, when it is expanding within the pipe, it will create unnecessary pressure on the walls of the pipe, and that might lead to the pipes bursting. So that one will be an effect. So that is what we can say about the expansion and contraction of liquids. So the next lesson we shall discuss expansion and contraction of gases, because gases also, just like any other state of matter, expand when heated and contracts when cooled. So have a nice time.